I'm Sandeep Kulkarni. Welcome you to Dynamic Foundry Group YouTube channel. Today we are going to see a small video on grade-wise runner riser separation. This is going to be a very important topic for all of us. Runner riser is very important part of the melting section discipline. Most of the foundries do not give more attention to this and fail in making good quality of metal. This will increase your alloy consumption as unnecessary element will be used for lower grades, and in higher grade you have to add them again to make up the requirement. So it is directly cost impact in your melting section. Also in case of ductile iron, due to mix of cast iron riser, they fail in ductile iron grade, and there are chances that your ductile iron will become cast iron. If the cast iron riser mixed up with ductile iron, the sulfur level goes up in the bath metal, and to tackle that higher sulfur level we have in the bath metal, we have to add more ferrosilicon magnesium alloy. This will increase your melting cost by almost 0.75 rupees per kg. Also, if the RR, that is an riser of 500 bar 7 or 600 bar 3 or perlitic grade are used in the lower grade, that is a ferritic grade like 400 by 15, we get unnecessary copper manganese in the grade of ferritic structure, that is 400 by 15. This will increase the hardness and the perlitic matrix in lower grade, which will definitely affect your quality of the casting, as well as it will be a direct loss in terms of rupees. Also, if the runner riser of ductile iron, that is AG iron, are used for cast iron, then one has to use more CRCA scrap to compensate the charge mix. This will require more ferrosilicon and GPC coke, and thus cost of melting will get increased by about rupees 1.5 per kg of liquid metal, which is huge impact on the costing. Here we need to first put some identification later on each grade pattern on their riser and runner bars, so that we can able to identify them from the heap of the scrap and separate them accordingly. Next step is to separate them grade wise and keep them grade wise in a separate bins or in separate compartments to avoid the mix up. Use them grade wise to reduce cost and to maintain quality of the metal as per requirement. Here there are some of the photographs. You can see a later 5 is put up showing it is runner riser of 500 bar 7 grade. Similarly, you can see it on the casting, that is the runner riser itself. After short blasting, you can see these 5 and 6 are identified easily. It is also identified in the melt. This shows that this is 500 bar 7 or perlitic grade metal charging is going on, because we are seeing the runner riser of 5.6 in the charge. These are some of the photo how you can use the compartment to separate out the runner riser of various grades. Some of the photographs I have collected from various foundries. I'm displaying here for your reference how you can separate out the runner risers of various different grades accordingly by using proper identification. So proper arrangement of the grade-wise riser separation is a systematic way will help you improve melting quality and reduce cost. So this is from my side. Thank you very much. Hope this video will be helpful for you. Thank you.